Good morning and welcome to the next episode of the Tapir tutorial series. So far we've been describing endpoints with a single input and a single output. Last time we added also a single error output. But of course in real-world applications you most often have multiple inputs and multiple outputs. So inputs might include query parameters, path parameters, headers and the body. The output might include also headers, the status code and the body. So let's see how we can describe endpoints which have multiple inputs and multiple outputs, how we can map them to high-level values. So let's start. To demonstrate how this works, we will develop an endpoint which will be called operation. It will accept an operation name as the second path segment. It will also accept two query parameters. The operation name can be add or subtract, and the result should be given in the response body, either the result of the addition or subtraction, and we will additionally require that the hash of the result, when represented as a string, is also returned as a response header. So that's as you can see, we have multiple inputs and we have multiple outputs. So let's see how we can describe this as an endpoint. So we will create an op endpoint, and we start as usual with the endpoint value, which describes an empty endpoint which has no inputs and no outputs. Adding multiple inputs is actually a matter of calling the .in method multiple times. So let's do just that. So it will be a get endpoint. It will have a path input called operation, and then we want to capture the second path segment as a value. So it will be a string. It will be called opName. So the name here is used in documentation. Other inputs include a query parameter called value1 and another one called value2. So as you can see, we have simply added three inputs to our endpoint. And that's it when it comes really to supporting multiple inputs. But let's see how it actually influences the way that we have to provide the server logic. In the same way, we can add multiple outputs. So we will, as an output, we will specify that we want to return a string body. This will be the result of our operation, and another output will be a header represented as a string called x result hash. Okay, we will also specify an error output. So we only accept operations where opName must be equal to add or subtract. So if the user provides the wrong operation name, we need to let them know that something is wrong. We will actually see how to better handle such path components and query inputs and inputs in general, which are enumerations, in future tutorials, so that Tapir does this validation for us. Okay, but we've got this multiple inputs, multiple outputs. So what happens when it comes to providing the server logic? So by default, each input, the way it works is that it extracts some kind of value from the HTTP request, right? So the query input over here extracts the value of the query parameter. The path input over here extracts the value of the input of the path component, right? So when we have multiple inputs, by default they will be extracted individually and then they will be combined into a tuple. So this combination also is not there's one thing that needs to be mentioned about this extraction, because we have some inputs which provide values and we have inputs which don't provide values, right? So we have 5 inputs in this endpoint, right? First we have the constant method input that matches only the get method. Then we have the constant path input. We have the path segment input and 2 query inputs. So these two, so the constant method and the constant path inputs, they don't really extract any values from the request, right? They're only used to match the endpoint to the request, right? So the request comes in and we have to see if this request matches this endpoint. So these constant inputs are used for the matching part. But then we also have the extraction part, right? We want to extract the second path component. This is in fact also used for the endpoint matching, because this endpoint will only match the request if it actually has exactly 2 path segments. But this input is, in addition to matching that the path component must be there, it also extracts its value. Same with the query parameters. So these 2 inputs, the constant method, constant path inputs, they don't contribute anything to the tuple that is extracted from the request. So we have 5 inputs, but only 3 inputs contribute to the values that are extracted, right? So as an input to our server logic, so we will want to provide the server logic over here, we will have an input, a tuple string int, right? So the types in the tuple are in the same order in which the inputs are added to the endpoint. In the same way, the server logic must return a tuple, which is then mapped to the response. So here we have 2 strings. So the first string will be mapped to the body, the second will be mapped to the header. So we must return a string tuple. This must be also wrapped in an either, because we have error outputs here, right? So we must return either an error, which is simply a string, or success. So success here means these 2 outputs. Okay, so now we have to implement our server logic. So we use the handle method, which is used to provide server logic in case of our synchronous setup that we have here. So we can see that IntelliJ in fact knows very well the shape of the method that should be provided, so everything is checked at compile time. If we provide the wrong method of the wrong shape, this will become a compile time error, right? So we need to provide a function which converts the values that are extracted from the HTTP request into values that will be mapped into the HTTP response, right? So we have the op name as the first tuple parameter, value 1, value 2. Okay, so now we just have to match on the op name. In case it's an add, then we return a write consisting of we will actually add a helper method hash, which will hash our result to the output string. So the first parameter will be the result as a string, and the second parameter will be a hash. So we will just use some built-in hashing that's available in Scala. So this will also result to string dot to string. So the hash is also a number, so we convert every number to strings, right? So that's in fact the core of our logic, which converts the result of our operation into the body and the hash that we also want to return. So okay, so in case of an add operation, we return the hash of value 1 plus value 2. Okay, in case of subtraction, we return the hash of the difference. In every other case, so the operation is invalid, we say it is an unknown operation. Available operations include add and sub. Okay, and that's in fact, I guess, it, right? So once again, we have 3 inputs, and they contribute 3 tuple to the value. That's the value that's extracted from the request. As a response, we have to return either an error or a 2 tuple, which will be mapped to the values over here. So let's actually try running this, and we'll see if it works. So we have the standard set of dependencies over here. So we have the core Tapir module, which allows us to describe the endpoint, and we have the synchronous native server, which allows us to expose our endpoint as a server. We also have the standard set of imports, and so we can get rid of this, and we can uncomment the way the server is started. Okay, so I guess we can now do some testing. So let's first run our code. Okay, it compiled. So let's do some curls. So here we subtract 10 and 8, so this should be 2 probably. You can see the result is 2. There's also the header, right? So we can do some other operation, maybe 10 minus 5 is 5, and you can see that the hash is different. We can also add these two values, and hopefully it's 15. And in case of a multiplication, we should get an unknown operation. So this works nicely. Okay, great. But it's not perfect, right? The signature of our server logic is quite ugly, right? It operates on a 3-tuple string in int and produces a string tuple. So if you would be reading this code, you wouldn't really know like what it's about, right? What is this string? What is this int? It doesn't have a name. Tuples are useful, but they also can be hard to understand when they are overused. So we will try to do something to actually not rely on such nameless tuples too much. Instead, we will use named tuples in a way, right? So we will use case classes. So what we will do is we will define two helper classes called input, case class input. It will have an op name, which is a string, value 1, which is an int, and value 2, which is an int. And we'll have a case class output, which contains the result as a string and the hash as a string as well, right? So we will try to actually map these values that are extracted from the request to the input class, right? So that our endpoint says that it extracts the instances of the input type and it maps instances of the output type to HTTP responses. So our goal is for the server logic. So our goal is for the server logic to have a signature that it takes input and it produces either a string or output. So that's already much better. And I think if you would see that an endpoint has a server logic with this signature, it would be much easier for you to understand what's actually happening in the code. Okay, so let's see how we can do this. So what we need to do is we need to map these values that are extracted from the HTTP request to this to instances of the input class. So once the inputs are all defined, what we can do is we can call mapIn. So the mapIn function takes in the tuple that is extracted so far and returns some other type, right? So here we take the op name v1 and v2 and we return an instance of the input class, which is simply quite boring code which creates an instance of input based on these values. But that's not all. We also need to provide the conversion the other way. So this conversion from the tuple to the input instance, this is used when the endpoint is interpreted as a server, meaning that a request comes in, the values for the individual inputs are extracted, the tuple is created, and then this conversion function is applied. But an endpoint can also be interpreted as a client. So we didn't cover it yet in the tutorial, we will in a future episode, but when it's interpreted as a client, we need the conversion the other way, right? So when you do a client call, you provide an instance of the input, and this needs to be mapped to the request that is then sent to the server. So we also need to provide the conversion the other way. So given an input, we need to return a tuple with the op name, v1 and sorry, it's value 1 and value 2. Okay, hopefully this will compile. So we have the mapping done. So now you can see that this is red over here, right? Because the signature of the server logic that we need to provide changed. So we actually don't get a tuple here, we will get an instance of the input class. So we can say that input over here, and we need to match on the input .op name, and we need to refactor things a bit over here. But once we do, things should work fine. You can see that the signature of the server logic now changed to so the server logic is parameterized with instances of the input class, because we have mapped the inputs over here to an input instance, and the output is still unchanged, right? and this still works. You can see in the terminal that yeah, things still work, so things still compile. Okay, so one important note here is that we apply the mapping only after all inputs are defined, right? So the mapping takes into account the inputs that have been added so far. We can of course add more inputs later, so we can like add a third query input over here, but this would mean that now the shape of the server logic would be once again a tuple. The first element of the tuple would be the inputs defined so far, so it would be of type input, and the second parameter in the tuple would be an int from this third value, right? So if we add more inputs later, we will once again go back to our tuple situation, and we can of course do more mapping, so we can apply .map in once more over here, and so on into multiple layers of inputs if that's necessary. Okay, so our code is slightly better, but actually, you know, this code over here is very boring to write, especially if you have to do it many times over, right? So we can do better. There is a macro in Tapir. A macro is a piece of code that's run at compile time, and it generates some more code. So macros actually help you avoid a lot of boilerplate quite often. So what we can do over here is we can just remove this line. We can call the map into, and the map into macro takes as a type parameter the case class to which the tuple extracted so far should be mapped. So in our case it's input. So if you look at the generated bytecode, it will be more or less the same as if the map in invocation that we had before. So the macro will generate this boring two-way conversions between the tuple and the case class, and from the case class to the tuple for us. Okay, as you can see, this still compiles. We can also use the map out to output. So now our signature changes because we have to return an output over here. We can actually just change our class over here to return an output. Okay, and we have our hash function. So everything compiles because this returns an output, and we wrap it with a write. So this all works nicely, and we have a quite nice signature of our server logic function. So let's just verify quickly once more that things still work. Okay, and let's try running a request. So 10, yeah, that's what's the multiplication. So let's add the addition. 10 plus 5 is 15. Awesome. Okay, so that's it. So just as a short recap, if you want to add multiple inputs to an endpoint, just call .in multiple times. Each input that actually extracts a value from the request will add a new element to the tuple that is extracted from the request as a whole, and that tuple can be then mapped to your custom type using .mapIn. If you have a case class, this can be simplified by using .mapIn too. So actually, you know, supporting custom types is very important in a library that's oriented towards compile time safety. So we have seen how to do it with JSON bodies in previous episodes. Now we have seen how to do it, how to support some custom types which wrap multiple values which are extracted from requests or which should be mapped to responses. We will also cover some more on how to support other custom types later as well. And for now, I think that's it. So thank you very much, and see you next time.